So as usual, I've already done literally the whole paper, and I'm just going to discuss every single one of my solutions based on every single question. So without further ado, let's go. Now, number one. So the continuous random variable x has the cumulative distribution function. Okay, so here we go. So here's the capital F. So this is all accumulating the small probabilities. Okay, so it's an increasing function. Now, A, find the upper quartile of x. So first things first, an upper quartile simply means the first 3/4 of the distribution, or in this case, the 75th percent. So essentially, all you're trying to find exactly is when does the function equal 75%, at what point. So thankfully, we're given every single detail. You know, we're not going to use 0, 1 because this is right at the beginning, this is right at the end. So the only common sense value to use will be the middle one. So I just said, okay, let f equal some third quartile value, and this must equal the 75th percent. So replacing fq3 with this equation here, just solve for q3, and that's it. You get it. It's 7.5. Very straightforward. I also added a graph as well, just so you can have a visual representation. My advice is to always do something like this because it just kind of helps you see where certain things are. It's quite useful in my opinion. Now, anyway, let's look at part B. So find the mean and standard deviation of x. Okay, so to find the mean and to find any of these two variables, we firstly need to find the probability distribution function or probability density function. So we need to find the small fx. To do this, we can just literally differentiate this equation. So just quick tip, if you're finding the cumulative from the density from the small f, to go from small to big, you need to integrate. To go from big to small, you need to differentiate. So kind of relate the capital letters and small letters with differentiation and integration. Anyway, differentiating this is quite straightforward. You could just ignore the 1/6, differentiate inside and get 1. So 1 times 1/6 is 1/6. Or expand it, either way is easy. And then you're going to do, and then this is of course 1/6 for these values here, because that's what the limits were. Now to find the mean, it's just simply x times the density function, so x times 1/6, and you just integrate from all the regions from 3 to 9. Doing that, you should get 6 at the end. For the standard deviation, we need to firstly calculate the variance, and the variance is simply the integral of x squared times the density function, so x squared times 1/6, minus the mean squared. So it's literally the expected value of this of x squared, like ex squared, minus the mean squared. And then yeah, integrating this is easy. You just get x to the power 3 over 3 times 6, which is 18. Dropping in the limits of 9 and 3, minusing mean squared, and boom, you get 3. And hence the standard deviation is just the square root of the variance, which is √3.